All right, let's review algebraic equations, writing them to solve real-life scenarios. Here are the three steps we're basically going to use. We're going to read the problem, we're going to define the variable, and in order to do that, we're going to basically ask ourselves, what is the problem asking us to find? And then we're going to translate the words into what they mean mathematically, piece by piece. Here's an example. 7/9 of the cars on the road were sedans. This was equal to 224 sedans. How many cars were on the road? All right, so the very first thing we're going to do is we're going to define our variable. What does the question ask us to find? Well, it says how many cars were on the road. So we'll let C represent the number of cars on the road. And then after we do that, we can go ahead and break this down piece by piece and translate each piece. 7/9 means 7/9. We'll write that down. But then it says the word of. And here's a reminder. When you have a number followed by the word of, usually it's a fraction or a percent, then followed by the word of, then it will mean multiplication. So back to our problem. 7/9 of means 7/9 times. Times what? The cars on the road. Well, remember, our variable stands for the number of cars on the road. So that'll be 7/9 times C. And we don't need a times dot between a number and a variable, so no need. We'll just put the C right next to it. Then it says this was equal to. Well, that obviously means the equal sign. And then finally it says 224 sedans, so it'll be our 224. You'll notice on most of these word problems, going in the order that we read it when we write our equation is pretty much the way that we are going to get our equation. Problem number 2. The -8-degree temperature was 22 degrees less than the temperature last week. What was the temperature last week? Let's define our variable. We will let T represent the temperature last week. And then we can break this down piece by piece. -8 means -8. 22 degrees means 22, but it says 22 degrees less than. Let's refresh your memory. The phrase less than is going to mean subtraction, but the order switches. So on our problem, it said 22 degrees less than, as I have highlighted in green for you. That does not mean 22 and then minus. It actually means something minus the 22. Well, what's that something? Read the part in blue. The temperature last week. Remember our variable represents the temperature last week. So the T will go to the left. So the order that we saw it in the words, it will switch whenever you have a phrase like less than or shorter than or fewer than or any two-word phrase that includes the word than, that would mean subtraction. Now, there's something else I want to remind you about. The word is or was can possibly mean the equal sign. Now, not always. It has to make sense in the context of the problem. Well, this problem did have the word was. Is this going to mean the equal sign? Well, it would make sense to have the equal sign to the right of that -8, since that was the only place left for the equal sign to go. So yes, that will be our equal sign. Problem number 3. Fred spent a total of $123. He bought one program for $15 and 6 tickets each for the same price. How much was each ticket? All right, so once again, the part of the question that is actually asking the question will be where we define our variable from. So let's let P represent the price of each ticket. And then once again, let's break this down piece by piece and translate as we go. 123 means 123. One program for $15 would be 1 times 15, but that's really just 15, so we'll write down 15. 6 tickets, as I've highlighted in blue. Well, 6 means 6. But then it says each for the same price. Here's a reminder. The word each, the word per, or the phrase for every, those words often mean multiplication. So when it says 6 tickets each for the same price, that's going to be 6 times whatever that price is. And if you think about it, whenever you buy multiple items for the same price, you would take the amount that you're buying, in this case 6, times whatever the price is for that item that you're buying. So it's very common in real life to take the number that you're buying times the price, and that's what we did here. Now on this problem, there are spaces in between. What are those spaces? All right, here's something else to remind you of. When we in real life find totals, we often add the parts together. Well, on this problem, we are spending a total of $123. How can I equal that total? By taking the $15 for the program and the money that I spent for the tickets and add those pieces together. This is a big idea on a lot of algebraic equations that we write, that to get totals, we add pieces together. Problem number 4, the last one I'm going to give you here. Asha bought 4 lamps, each for the same price. At the cash register, she gave the cashier a $25 coupon. If the final price she paid was $62.92, what was the original price for each lamp? You might notice on this problem, it actually tells me what variable I should choose, and it's placed appropriately at what it represents. So on problems like this, you do not need to define a variable because it has already been basically defined for you. So from here, let's break this down piece by piece. Asha bought 4 lamps. We know 4 means 4, but it was each for the same price. You heard me say this before. The word each often means multiplication. And here it makes sense to take 4 times the price for each lamp, which again, we call that P. Now, $25 means $25, but it's a $25 coupon. Now, yes, I've told you that to find totals, we usually add things together, but a coupon, if you think about this in real life, will take money off of the price, and therefore that's going to be subtracting it away from the price. So we are not going to add by 25 because if it's a $25 coupon, we will subtract that away from the price of the 4 lamps. We know the final price was $62.92. This is supposed to be an algebraic equation. Equations have equal signs, and there's only one logical place for the equal sign since we filled everything else in. That's going to be right there to the left of the $62.92. There can be many other phrases that problems could possibly use that can mean subtraction. Could be things like was removed, or decreased by, or a withdrawal that was made at a bank, which takes money out of your savings account. So keep in mind, there are plenty of phrases that can mean subtraction, and even though we often will add things together to get a total, we have to keep in mind things that could mean subtraction.